Dear students, welcome to this first lecture on states of matter. And from this lecture onwards, we will going to discuss different topics that is been included in your syllabus of class 11 state of matter chapter. There are basically 5 states of matter. The 5 states of matter are: number 1, that is solid; number 2, that is liquid; number 3, that is gas. These 3 states of matter we all know, but another, that is 4 number, that is plasma, and 5 number is super cooled solid. These 2, that is plasma and super cooled solid, that is among the 5 state of matters. Let us understand these 2 state of matters, but we will concentrate only on the 3. The plasma is basically the state of matter that has been achieved when the gas has been in the higher state. Higher energy state means that there is a higher temperature has been given to the gas, that is achieved in case of your sun or in case of star, where there is a higher excessive amount of heat is there, and at that time what is going to happen, the electron has been coming out from the atoms and there is a positively charged ions also there. It is basically mixture of electrons and positively charged species. This is called the plasma state. And supercooled solid state, it is a state, it is basically created artificially. That is, it is also called the Einstein-Bose condensate. When the atom has reached in its level, it has a very little energy. At that time, atom will lost its identity and it will become condensate and it will create a super atomic positions. The atom will be converted in the super atoms, and this state is called the super cooled solid state. But we will not concentrate on this 4 and 5, the plasma and super cooled solid. We will only be concentrate on this 3 state of matters. But in the solid, that has been will be taught in your class 2, that is in the 12th class. And here liquid and gas we will be covered in these sections, in this class 11, that is in this chapter we will going to cover it. So now question arises, what is the basic question that we are going to understand in this lecture itself, that what are the reason behind the 3 state of the matters, that we are going to discuss in this lecture. And this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So let us understand what is the reason behind the 3 state of matters, that is solid, liquid and the gas. Basically, it has been observed there is the 2 energies. Number 1, intermolecular interaction energy. And number 2, that is the thermal energy. Both this energy going to be responsible for these 3 states of the matters. How there? It is basically the balancing of these two energy that going to create all these state of matters. You can understand easily that this physical state, if you see the properties of the physical state, that is solid, liquid and gas, you will see that there is in the solid state, the molecules are very closely packed, less closely packed as compared to the solid. In the gaseous state, the molecules are far apart. And if you see the energy in case of the gaseous state, the molecules having least energy as compared to the liquid and the gas. Liquid having the energy of the molecules will be higher than in case of the solid, and in the gaseous state it is molecules are highly energetic state. So both these, the properties of this solid, liquid and gas, it will help us to understand how they are being transformed to each other, that what is the reason behind it. It is basically the intermolecular interaction energy. It will keep the molecules together. It will help to keep the molecules together. It will help to keep the molecules together. And thermal energy, it will keep the molecules far apart. So balancing these two things will create the three state of matter. So understand, that is basically the intermolecular interaction, means intermolecular attractive force. It will keep this molecule together, and whereas the thermal energy keep this molecule far apart. When there is a very little interaction between the molecules, it is very hard to produce the liquid or the solid. Until and unless we take out the thermal energy by way of reducing the temperature from these molecules, that is not possible to liquefy. Gas cannot be liquefied by compressing it. Suppose this is a gaseous state. This is a gas, this is molecule are far apart. You can compress this gas, and in this process what is going to happen? The distance between the molecules will be much less. But that will not going to help us in transforming this gas into the liquid. How? At that time what is required, that thermal energy we have to reduce to the substantial extent by reducing the temperature. By reducing the temperature, you can able to reduce the thermal energy. When this thermal energy reduced, at that time there will be that transformation from the gas to the liquid is possible. So both the things we have to do simultaneously, that is by compressing the gas and by reducing the thermal energy, and we can able to reduce the thermal energy by reducing the temperature. So there is a balancing between this intermolecular interaction energy and thermal energy, which is going to create these three forms of the solid, three forms of the matter. The matter has three forms: solid, liquid and gas. And when the thermal energy is predominant over the intermolecular interaction energy, then you will find there is a tendency to go towards the gaseous state. At the same time, when the intermolecular interaction energy is predominant over the thermal energy, at that time you will find there is the there is the solid state or liquid state is going to be predominant at that time. So we can write this. This is solid, liquid and gas. When the thermal energy predominates, then you will find this transition, that solid will convert into liquid, liquid will convert into gas. But at the same time, you will see it will be reverse. When the intermolecular attractive force predominates, then the process from the gas to liquid to solid. So it is basically the balancing between these two things, that is the thermal energy and the intermolecular attractive forces, or you can say intermolecular interaction forces, that is going to be responsible for the three state of matters. Now we will understand that about the thermal energy and about the intermolecular interaction energy, how they are basically, that we are now going to understand. This lecture is basically the introduction to state of matters. I think it is now clear why there is a three state of matters. It is basically the balancing of the two energies, that is internuclear interaction energy and the thermal energy. Now we are going to discuss what is thermal energy. Thermal energy is basically the energy which comes out from the motion of the particles in the body, and it is directly proportional to the temperature, and we can able to calculate the thermal energy from the average kinetic energy of the molecules, and the motion of in the body is responsible due to this thermal energy. So we can write thermal energy, it is responsible for the motion, of the particles. And we know particles having the three type of motion. One motion is basically three type of motion we can see. One is translatory, that is the motion of the particles in a straight line. This is called as translatory motion. Another is rotatory, and next is vibratory. So you can see there is a three type of motion, and from this motion the thermal energy is been there in the body. That is translatory motion, rotatory motion and vibratory motion. And you can see in the solid these two motion is not possible. It's not been observed, whereas this vibratory motion is observed. In solid So we can write this in solid. The two motions is not present, but this vibratory motion is present. But in case of gas, this transitory motion, this rotatory motion and the vibratory motion is there in case of liquid. And in case of gas also, this level intensity of this motion is much more due to this thermal energy. That is translatory, rotatory and vibratory. Three type of motion you can able to find in case of gas, whereas in the solid you cannot able to find this type of motions, only you will find the vibratory motions. So this is the one responsible factor for the three state of matters. Another that we are going to discuss, that is the intermolecular interaction forces. And this intermolecular interaction forces can be achieved, can be observed in different ways that we are going to discuss. Interaction between the molecules, that we are talking about the attractive mutual forces that is going to be there in the molecules. Number one, that is dipole-dipole interaction. Dipole-dipole interaction. This type of interaction normally observed in case of polar molecules. In case of polar molecules. Polar molecules, as for example, that is HCl. HCl, NH3, all are the polar molecules and they have the dipoles. And one dipoles having the positively charged and another pole is negatively charged. And what is going to happen? The HCl, suppose this is the HCl. Here you can see it is plus and minus, and this will be attracted Cl minus, that is Cl minus, that is the one portion is negatively charged and other portion is positively charged. So this negative portion will attract the positive portion. So this is called the dipole of this molecule and it will attract it with each other and you will call the dipole-dipole interactions. Second type of interaction is ion dipole. In the ion dipole interaction, you can see that when we dissolve NaCl, sodium chloride, in the water, here what is going to happen? Na plus and Cl minus will be attracted by the H2O. H2O having the dipole moment. It is a dipole has been already created in H2O and it will attract the negative point of this H2 molecule will attract the positive in Na plus and the positive point, that is H ion, will attract the negative point. So you can see that Na plus ion, that is will attracted by the O minus and it is O minus and O minus. So oxygen ion is negatively charged and it will be create a interaction, that is a attractive interaction between this. In case of Cl minus ion, you will find this also. So now we understand this Cl minus will be attracted by this H plus ions, this H plus ion, this H plus ions, and it will have the interaction of the attractive interactions. Then another type, that is number 3, is ion induced dipole. Ion induced dipole. In this case you can find, so we can understand the NO3 minus ion will be attracted by the I2, and the I2 will be, there is a dipole moment is created by this NO3 minus ion, and you will find there is a interaction between this. And there is dipole induced dipole. In this case, when dipole molecule will approach to the non-polar molecules, as for example, this is the dipole molecules, and when it will come near to this molecule from these atoms, which having the electron density is symmetrical, at that time dipoles will be created in these non-polar molecules, and it will be created by this. And in this fashion, what is going to happen, there will be the attractive force created between this dipole. This dipole has been induced to this non-polar substance, and it will create the dipole induced dipole interactions. 5 point, that is in this case the two non-polar molecule or atoms going to create this type of interaction. With the time when the electron is revolving, it will create some unsymmetry in the electron charge. So when this will create an unsymmetric electronic charge, it will having the temporary dipole moments, and these temporary dipole moments will induce dipole to that molecule, nearby molecule, and these induced dipoles and these temporary dipoles will make a positive interaction with each other. That you can see, normally this molecule will be like this, there is a symmetry, and temporarily there is a dipole created. That electron density has been shifted to one portion, and this will induce the dipole here also. And at that time, this dipole will induce dipole and the temporary dipole, that is going to create the positive interaction between them. And this type of dipole is called, this type of interaction between the temporary dipole and temporary induced dipoles is called the London forces, or it will also called the dispersion forces. Now, among these 2-3 forces are jointly called the van der Waals forces. Van der Waals forces, that is dipole interaction number 1, dipole interaction, this will be, we can call it, then we can call the London forces or dispersion forces, also London forces, also the van der Waals forces, and another, that is dipole induced dipole induced dipole. Both these are called, 3 interactions, attractive interactions, are called the van der Waals forces. So now we understand the van der Waals forces and the thermal energy, and this is going to create the different state of the matters. I think that is very much clear to you. So this is the introductory of this state of matter chapter. This is a very easy chapter. Now in this lecture we have discussed about how there is a 3 different states of the matter and what is the reason behind it. This is basically the 2 energies that we have to think over. That is one, that is the intermolecular attraction forces, and another the thermal energy, balancing of which create the 3 state of matters. When thermal energy predominates, then we will find this gaseous state or liquid state. But when the predominance of the intermolecular forces over the thermal energy, then we will find the solid state. So that is all for today's lecture. Next lecture, from the next lecture, we are going to start the gaseous law, and also we will start other things that will be in your syllabus. Thank you very much for watching.